Hey everyone. As an architect, I've seen a ton of teams get the micro part of microservices right, but really struggle with making them resilient. You know the drill. We spend so much time writing retry logic and timeout handling in our application code over and over and over again. Well, today, we're going to change that. We're going to take all that critical resilience logic and pull it completely out of our applications and into the Istio service mesh right on AKS. So let's start with a simple but really powerful question. Where should your code fail? See, for way too long, we've treated failure like it's some kind of accident. But in any distributed system, failure isn't an if, it's a when. The goal is to stop letting failures happen to us and start designing failures that happen for us. It's all about moving from chaos to control.
So here's our game plan for today. First, we're going to dig into why microservices can be so fragile. Then, I'll introduce the service mesh as the answer. After that, we'll get hands-on with configuring Istio's resilience features, cover the absolutely crucial step of testing your policies, and I'll wrap it all up with 5 key recommendations you can take with you.
You know, here's the core problem. Every single time we add a new microservice, we're also signing up for this hidden tax. We have to build, test, and then maintain all this resilience logic, things like timeouts and retries, inside every single service. This creates a ton of complexity, and what's worse, it leads to massive inconsistencies across the whole system.
And this slide just says it all, doesn't it? On the left, you've got your beautiful, clean business logic. This is what your service is actually supposed to do. And then on the right, that same logic is just getting choked out by this tangled mess of resilience code. Now, just imagine that clutter multiplied across dozens, maybe hundreds of services, each with its own slightly different implementation. It's a total maintenance nightmare, and it pulls your developers away from building the features that actually matter.
This is exactly where the service mesh comes in. Seriously, think of Istio as a dedicated co-pilot for your microservices. It sits right there next to your applications, and it takes over the really hard job of navigating the unreliable network, so your application code can focus purely on its primary mission. Okay, so to make this feel a little more real, we're going to use a simple but really critical call chain for our examples today. We've got an API service, which calls a payment service, and that in turn has to talk to some external payment gateway. A failure anywhere in this chain can have a pretty big impact. So how does this magic actually work? Well, Istio deploys this tiny, super efficient proxy, it's called an Envoy proxy, right alongside each of your services. This proxy transparently intercepts all the traffic coming in and going out. And because it sees and controls everything, it can apply these incredibly powerful rules for things like security and traffic management. But for us today, the big one is resilience. And the absolute best part, it can do all of this without you ever having to change a single line of application code. All right, let's get our hands dirty and build our blueprint. We're now going to apply 3 of the most important resilience patterns, timeouts, retries, and circuit breakers, to our example call chain, all just using Istio's simple configuration files. First up, the timeout. This is your most basic, your most fundamental line of defense. It basically just asks the question, hey, how long am I willing to wait for a response before I just give up? Setting good timeouts prevents a single slow service from creating a domino effect of delays across your entire system.
So here's a really concrete example. We're applying a simple 2-second timeout on any call that goes to our payment service. If it doesn't get a response back in time, it still just ends the request right there. The benefit is immediate. We fail fast. This releases the resources back on the API service, preventing it from getting stuck and allowing it to serve other users.
Next, let's talk about retries. Look, the network is not perfect. Little transient blips happen all the time. A retry policy automatically reattempts a failed request a couple of times, which can often turn what looked like a temporary failure into a complete success, making for a much better user experience. Not, and this is a big but, the key is to be intelligent about retries. Here, we're telling Istio to retry up to 3 times, but only if it sees a 5xx server error. We absolutely do not want to retry a 4xx client error, like, say, an invalid credit card number, right? That kind of intelligence now lives in our mesh configuration, not scattered all over our application code. And finally, the circuit breaker. This is a critical pattern for keeping your whole system stable. Think about it. If a downstream service is struggling and failing requests over and over, the absolute worst thing we can do is keep hammering it with more traffic. A circuit breaker is smart enough to detect this pattern and temporarily stop sending requests,
giving that struggling service some breathing room to recover. So here, we've configured Istio to keep an eye on the payment service. If it sees 5 consecutive errors, bam, it trips the breaker. For the next minute, any new requests are failed immediately on the client side without even trying to contact the overloaded service. This is so critical. It gives the struggling service time to get back on its feet and prevents a small local problem from causing a total system outage. Okay, so this all sounds great in theory, right? But now for the reality check. We've set up all these powerful policies, but how do we know they're actually going to help during a real incident and not, make things 100 times worse? Well, the answer, of course, is that we have to test them. I really can't stress this enough. A resilience policy is just a theory. I guess, really, until you've tested it under fire. A poorly configured retry policy, for example, can easily create what's called a retry storm that can amplify a tiny problem into a catastrophic system-wide failure. You have to validate your assumptions in a controlled environment. And this is what that validation actually looks like. We simulated a partial outage by making 10% of our payment pods unhealthy. And the chart shows the result. Istio's circuit breaker correctly tripped for those failing pods, instantly rejecting that 10% of traffic, while the healthy 90% just kept on succeeding. This is exactly what we want. This is controlled failure by design. So the goal of all this testing is pretty simple. Prove that your policies are helping, not hindering. You want to confirm that your timeouts are reasonable, that your retries aren't going to accidentally crush your backend services, and that your circuit breakers are doing their job of isolating failures effectively. To wrap things up, I want to leave you with 5 concrete mesh-level settings that I really recommend as a baseline for any production Istio deployment you're running on Azure Kubernetes service. First, set a sensible default timeout across all your services to prevent any one service from locking things up. Second, implement capped retries, but only for idempotent calls. That is, operations that are safe to repeat without weird side effects. Third, establish some global circuit breaker defaults to act as a last resort safety net. Fourth, enable Istio's outlier detection, which automatically kicks unhealthy service instances out of the pool. And finally, enforce mutual TLS. Now, this is a security feature, for sure, but it also improves reliability by making sure services are only talking to the authenticated endpoints they're supposed to. Look, if you remember just one thing from this whole explainer, let it be this. By offloading all that resilience logic from your application code and into the service mesh, you create cleaner, more consistent, and just vastly more manageable microservices. This empowers your platform team to manage reliability globally, and it frees up your developers to do what they do best, build great features. So I'll leave you with this final thought. Once you've established this resilient network foundation with a service mesh, you've unlocked the ability to tackle even more advanced challenges. So what's next for you? Is it fine-grained traffic shifting for canary releases, advanced security policies, or maybe deeper observability into your applications? The possibilities are now wide open. Thanks for spending the time with me today.